Sweet. Well, hey, good morning, everybody. Thank you for joining in on this session. So today we have JD, who is a product manager from Trimble, and he's going to be going over tracking and traceability as-built data collection with Trimble Unity GasOps. And so we appreciate everybody who's joining in on the session this morning. Just a few little housekeeping items before we go ahead and get started with the presentation. If you want to drop a comment or question, you can easily do that by just clicking the Live Now button on the left-hand panel of the conference platform. You can drop a question in on that little menu there. If you're having any technical issues, you can click on the little question mark at the bottom right-hand corner of your screen, and that will give you some tips and tricks on how to troubleshoot those. You can also leave the session if you need to hop off for another meeting or a session or anything like that. You can quickly leave it by clicking the three dots at the top right hand of your screen. And then we also encourage you to leave a review, any parting remarks at the end of the presentation as well. Also, just a real quick plug for our broadcasters and our sponsors. We appreciate all of our sponsors and partners for participating in the conference as well. So with that being said, JD, I'll go ahead and hand it off to you, and we'll get started.
Thanks so much, Matt. Appreciate it. So yeah, welcome everybody to CityWorks Innovate Conference 2021. As Matt said, today we're going to be discussing tracking and traceability as-built data collection with Trimble Unity Gas. So I thought we'd get started by talking a little bit about what tracking and traceability is, a primer, if you would. So tracking and traceability, as we refer to it in North America, is very much focused on the gas market itself. So PHMSA, the federal regulatory agency that's over the gas industry here in the U.S., proposed a rule, 49 CFR Part 192, a few years ago, actually. And the intention of this rule is to try and provide better documentation of what's going in the ground. So as everyone's aware, you know, in this digital age, we're all trying to create this digital twin of this data that we have, right, that's in the field, and also want to have a digital copy of all of that. And it has been very important for the gas industry to be able to try and track some of that information. You know, unfortunately, when there is an incident in the gas industry, it can very much involve, you know, loss of life at the worst, right? Or a lot of damage if there's an explosion from some sort of gas leak. So there's been a desire to try and improve this information that gas operators have as part of their larger distribution integrity management plans, but also just as a way to try and track all of this for the better. So part of this is better documentation of what's going into the ground, is a coming to a consensus on a barcode standard. In this case, it's the definition standard is ASTM F2897. That is the technical ASTM designation for this particular barcode standard. And the idea is that this barcode standard would go on all plastic pipe and components. And what this barcode will allow them to do is to record some of this tracking and traceability data, and then they're able to retain this for the life of the pipe. So it's recorded when the pipe is being installed, when the components are being put together and placed in the trench, you know, before they come back and cover up the trench. So it's normally happens during this as-built data collection when all this information is populated. So a little bit about more details on the tracking side of this. When we talk about tracking, what we're talking about is the location of where these pipes and the components were installed. So the actual, you know, high accuracy GNSS data collection of where these pipes and components were placed in the field. They also want to know the date that these components and pipe were installed, and also the individual who installed them, right? This is all important for being able to track if something was to go wrong. Some of the traceability aspects of this is being able to trace for a particular piece of asset, a lineage, if you would, for it. So who the manufacturer was, a production date of when this component was created, a lot code from that production run, and then things like the actual size. And there's a couple different designations. So you could have like an inside and an outside diameter size that's being traced as part of this, as well as a specific material that's that this pipe is or components are made of. The two of these that are really huge are the production date and the lot code, because as the industry does testing and evaluations on different products as it comes out, they may identify a run of valves, for say, that have a manufacturing defect. And it's very important for the gas operators then to be able to look through their system and identify where they may have installed some of these other components from the same lot code or from the same production date. So it's not just about being able to track what goes in the ground for documentation points. It's also being able to, once it's in the ground, be able to go back and relocate and find this stuff based off of some attribution that's there. You know, like I said, production date and lot code are the two main ones when it comes to trying to validate some QA steps with stuff. So the proposed ASTM F2897 barcode standard originally included all of this information. It had manufacturer, production date, lot code, size and material, as well as pressure rating, temperature rating, grade, and then an individual model of pipe and components. But these last four, the pressure, temp, grade, and model, actually didn't make it into the final standards. These are what actually managed to get through all of the process. So what we see as example up top here is the example of 16-digit barcode, and this barcode has different sections of it that is coded to store all of this other information. So the first couple characters store code that designates the manufacturer, then we could get the lot number, a production date, material, the component type, and then the different sizes, and the last character is reserved for future use or for a data check. Here's some examples of the tracking and traceability barcode that we've seen on different components. So it'll range all the way from a sticker that's placed directly on the component itself. We've also seen it being manifested as a separate tag that's included in a package for an individually packaged component. It may be a separate tag that's physically attached to the component itself. And then on the actual pipe, we have seen either from stick pipe or rolled pipe, it's typically laser etched on the side of the pipe itself. So, you know, this has been an investment from the manufacturers to include this information. And that's part of the reason why it's, you know, the mandate's coming down from PHMSA about it. And we've seen most manufacturers already take this into place and start including these barcodes directly on the assets themselves. So this leads us to how can we make use of this tracking and traceability data that the industry is doing. This takes us to our Trimble Unity for gas application. And what Trimble Unity for gas is it's our Trimble Unity work management platform that has been had some additional functionality to focus on these specific tracking and traceability workflows within the gas industry. So the different components of the Unity platform are our GIS mapping from the field side, right? So these are our mobile solutions where we can do high accuracy GPS mapping, as well as intelligent data collection workflows and tools for collecting GIS mapping and GIS updates. The other component is the mobile work management component to this, right? So this is field software and rugged mobile solutions that are able to track jobs that it can be created and assigned to users and implemented in the field. And then the third component of this is our IoT and remote monitoring. And this is what the component that we have that allows us to connect into our real-time IoT devices, provide operational awareness. That we have several other sessions about this as part of the Innovate conference, so I would encourage you to check that out. But what we're going to focus on for this is the GIS mapping aspect of it from the field side, right? So this is as-built data collection, taking this tracking and traceability barcode standard into use. But all of these different components, we can combine them together for our single platform for smart gas management and analytics. We're able to combine all these together to provide a solution that allows people to do all of this type of GIS mapping, your mobile work management, remote monitoring, and then based off of the data that's captured, we can include different alarming and event management. And then with this whole system of action that we're discussing as part of this conference, integrated back into CityWorks, we're able to make this data useful by providing operational insights and analytics on top of that data. Like I said, what we're going to focus on today is just from the field GIS mapping, this as-built data collection workflow. So part of this I mentioned earlier is our Trimble Unity for Gas web portal. This is where all of the data from your GIS is fed into so that you can see. It's not a copy of the data, it is your GIS data being fed into Unity web portal here to make it visible to see where all of your existing assets are. This is where you would manage all of your users that you have within the application, as well as create the different form design and templates that are going to be used for this different data collection processes. Part of what Unity offers us is very specific workflow creations, and we'll see an example of some basic workflow actions that could be created as part of these data collections processes. And this is also where once the data is collected in the field, it will sync back into this cloud-based platform to allow users to do initial QAs and look at the data as it comes back from the field in a near real-time environment, right? As this information is collected, as users are capturing this data in the field, it will sync back into this portal and allow users to see the data as it comes in, and you're even able to go in and make some edits and updates to it as needed. The other component for this is our Unity for Gas mobile application. So the mobile application itself is device agnostic. You know, we have iOS, Android versions, and Windows version to run on full Windows operating systems as well. We provide out-of-the-box support for all of our Trimble R series receivers, so we're able to support all the way from the R1 up to the latest R12i to give us a full range of accuracy requirements and capabilities, from meter accuracy to sub-centimeter, if that's what's required. We're also able to connect into our real-time correction systems, right? That's what allows us to get to some of these levels of accuracy using real-time corrections. The application works in a online or an offline environment, so there is a functionality for it to sync to the device, and then if you're in a disconnected state, right, you have all of that data still on the device. You're able to do all of your data collection, capture information just like you were connected, and then when you get back into a connected environment, everything will then sync back into the Unity web portal, and it can be updated back into GIS from there. And it also allows us to have our background maps and that GIS data for reference, right? That we're able to see where our existing network is as we're out there doing some of these data collection workflows. So now what I'm going to do is show you guys a demo of our Trimble Unity for Gas mobile application. What this, where this is going to start off at is we have a job that's already created in the environment and has been assigned out to the users, and we will pick it up from the mobile device itself. So let me bring this over here. Oops, wrong one, sorry. And this, for this example, I'm running Trimble Unity Mobile on an iPad. So this is, we have a little bit different layouts for our iPad configuration versus a smartphone, but it all is the same application, it all the same data, the same accounts and everything will work for it. So the first thing that we have to do is we have to log in. In this example, I'm logging in with my Trimble ArcGIS Online account, right? So we can use a single sign-on with your named Esri user. It allows me to log in with my Esri account. And what I'm presented with is a list of workflow apps that have been configured and assigned to my account. And based off of these workflow apps that I select, I'll have different workflows presented to me, different data collection templates, maybe it's inspections that need to be done, that sort of thing. So in this example, I'm going to be using my gas mapper workflow. So I'll just open that workflow app. And what we see here is as soon as I open up the workflow app, it gives me a list of jobs that have been assigned to my account, my user here on the left-hand side. I'm able to filter these jobs and search for these jobs and look for them in different ways. I can also click on the little app icon. Or in this instance, I'm actually triggering the sync here. So I'm go ahead and initialize the sync, and it tells me that I've got one new job assigned to me. Right? It gives me the notification I've got a new work order assigned. And if I were to select this job, I'm able to zoom to the location of that job on the map. I'm able to see all of my background data relative to it. And if I open the job up, I can actually get driving directions to it. So if I don't know how to get there, I can get driving directions, turn by turn driving directions. It'll open up either Apple Maps or Google Maps, whatever you're using. And then once I'm on site there, I also have this ability to do an accurate locate to that particular work order location. So maybe my driving directions can get me close, then I'm able to do an accurate nav locate back, and you'll notice as I rotate my device around, it's giving me this compass heading and a direction for the to where this work order is exactly. Also notice how at the top here I have this in progress button. This is part of our workflow that we can create. So we can create these different workflow actions that step us through different parts of the job itself. And based off of the workflow that we create, you know, we can present different forms and different pieces of data to the user as they progress through the job. So I'm just going to mark myself as in progress. And now the status of the job has changed to in progress. And we can see the status here on the left-hand side as well. And what we're looking at here at this job is some basic information about the job itself. So there's just who the user was, who it's assigned to. We can see different information about that work order itself. And so in this case, now I've clicked collect asset. I'm presented with a list of assets that I want to collect. This is all configurable through our Unity web portal. They can, users can create different templates for different data collection workflows or different processes they may have to go through, and then assign those to different workflow actions so that we can trigger these specific templates at the appropriate time. So in this case, I'm going to select a gas T as my new asset that I'm going to be placing in the field. It takes me to the form that I've created and we'll step through the different parts of this form itself. Now, these forms are fully configurable by the user, so you can have whatever information in here that you want to try and capture as you are filling this data out. So in this case, the first instance of the form, or the first data point on the form I have, is this EWN barcode. Now, what this is we've partnered with EWN, who is a OQ provider here in the U.S. And what they do is they're able to provide us with an employee badge that has a barcode on it itself, and this gives us specific information about this user in the field. So we mentioned earlier, wanting to track who the user was that did some of these different installations. Just by scanning that barcode, I'm able to populate this information about this employee. And we're also able to, as part of this workflow, is validate this badge. And we'll see later on in the last example of how this badge validation comes into play. The next step is where I would capture the geometry. So if I was connected outside with my external GNSS receiver, I would be using the GNSS signal coming through my device to capture that accurate position. But we also have this ability to digitize where the feature is, and that's what I'm doing because I'm here in the office. So I'm just zooming in to where the location is, and I'm going to manually digitize where that asset is. Now click the confirm button, and then it stores the latitude and longitude of where that feature was. If I was capturing this from a GPS, I would have lots of additional information like my horizontal accuracy, vertical accuracies, number of satellites, all that sort of stuff related to the GPS metadata itself. So now I can just walk through the different components, the different pages of this data collection form that we've put together. So now that I've validated that OQ badge, I'm able to fill out some feature info. So we have, in this case, it's a multi-selection. I can just hit a drop-down list and choose from a list, where I can do a yes, no. Here's another list where I'm setting the lifecycle status, selecting radio buttons to indicate the desired outcome. And then I can just continue to move on to the next part. And in this case, this is the barcode. So this is where we're actually scanning that ASTM F2897 barcode, that tracking and traceability barcode that contains all of this specific information about the asset itself. So they'll have the manufacturer name, lot code, production date, component material, that sort of thing. So we've got built into the Unity mobile application a scanner. In this case, we're using the camera to scan the barcode, but this would also work if you're using the one of our Trimble devices that has the optical scanner in the Empower module, like a Nomad 5 or one of the new TSC 7s. You can use one of those optical barcode scanners as well. So in this case, I'm just going to tap scan. It opens up the camera. I've got one of the tags here that I was able to scan, and we can see, and when I scanned it, it gives me the 16-digit barcode string up top, and then it automatically in the field live in real time will decode all of that barcode information into the correct manufacturer name, manufacturer lot code. So we have the production date, the all-important production date, the actual component material itself, what type of component it is, and then you can see we have different sizes. We also have, in this case, an ability to store attachments. So from Unity Mobile, we can capture a photo or an image, or a video from the device itself to store with the attachment. In this example, I'm going to use what we call a map capture. So it's going to open up the map view for me, allow me to zoom in and select the map view that I want. And then I'm able to do some redlining on top of there. And that's going to store all of that information, that redlining information with the image itself, and store it as an attachment on the asset. So now what I've done is just completed my first data collection process, and I've saved that, and now it takes me back to my work order, and I can either look at my list of forms now. So at this work order list, we track all of the forms that are collected at the work order level. And here I'm able to either view these on the map or do an accurate locate back to it, or actually edit it. So if I just were to view this on the map, it will zoom me back to that asset that I just collected. So now I'm going back to the work order and I'm going to collect another asset. In this case, I'm going to collect a distribution pipe. And we just walk through this process itself again. So I'm manually indicating the location of where the pipe is, drawing 2 points to make the pipe. And then I'm onto my next tab. My next page is the EWN. I scan the barcode. It populates all of the information for me. I can validate this badge. It takes me into the feature info. Again, just filling out some of this same information, examples of the different types of data formats that we can support. I'm just going to skip through some of this here as I fill some of this stuff out. In this case, I'm going to do another map capture. I'm going to take a photo and store a photo with the asset itself, and takes me back to the work order. Yes.
JD, sorry for interrupting. Just about 4 minutes left. Okay,
4 minutes, perfect. So as I go through here and I collect additional data, I'm able to see that in this example, I've filled out the EWN. I've scanned the barcode, but I haven't validated the badge, and so some of my form data isn't available to me. So once I validate that badge, now I'm able to go in, and all this feature info is now available to me. So this is some of our conditional formatting that we can do, validation in the field, making sure that forms are filled out correctly and needed. So again, I'm just filling this out. And then as I populate all my information, return back to my work order, I'm now able to click the workflow button up top to complete the job. I've marked it as complete. It shows up as completed now in my work order list. And as I trigger a sync to sync all this back into the web portal, it's going to sync all the attachments back to the server that I've collected, and it will actually remove this work order off of my list of work orders because now it's been completed. So that was kind of a high-level example of how we are able to use Trimble Unity Mobile to support these tracking and traceability as-built data collection workflows. All of this data is captured in Unity, can sync back into your GIS data where it can be used for further system of actions or operational insights. Matt, have we had any questions?
Thank you, JD, for the presentation. Haven't had any questions come through yet. Just a reminder, if you do have a question, all you need to do is click on that Live Now button on the left-hand panel, and then scroll down to the bottom, and there is a questions tab that you can input questions. If anybody is interested in more information, there's a lot more information at the Trimble sponsor and exhibitor page, and so feel free to visit that. There's some additional documentation, and I'm sure that there's folks that are willing to connect with you and answer any additional questions.
Yep, absolutely. Thank you so much.
All right, guys. Well, no other questions have come into the chat box, so we can go ahead and wrap it up. JD, thank you so much for the presentation this morning. It was very informative. And again, please do not hesitate to reach out if any of you have any other questions.
Thank you, Matt. Thanks,
Awesome.
everyone.